Hey everyone, and welcome. Today, we are tackling an absolute classic of system design interviews, building a URL shortener. Something like TinyURL. On the surface, it seems pretty simple, right? But what happens when you need to handle billions, and I mean billions of links? Well, that's where the real fun begins. All right, let's dive in. Okay, picture this. You're in the interview room, you're staring at a big, empty whiteboard, and this is the problem they give you. Now, your first instinct might be to just grab a marker and start drawing boxes and arrows, but wait, hold on. The single most important thing you can do first is ask questions. You absolutely have to understand the problem before you can even think about solving it.
So, that brings us right to our first section, sizing up the problem. Before we write a single line of code or design any component, we have got to figure out the scope and the scale. Let's get crystal clear on what we're actually building.
First up, let's nail down the core functions. Super simple, right? We need to take a long URL and make it short, and we need to take a short URL and redirect back to the long one. Easy. But just as important are what we call the non-functional requirements, the system qualities. It has to be highly available, scalable, and fault-tolerant. And we're going to add one little constraint here to make our lives easier: no deleting or updating links. And trust me, that one small decision is going to simplify our data model a ton.
Okay, with the features defined, the next huge question is about scale. How much traffic are we talking about here? This is where a quick back-of-the-envelope calculation is your absolute best friend. It takes this from an abstract idea to a concrete engineering challenge with real numbers. Let's just say your interviewer tells you the system needs to handle 100 million new URLs, and not per year, per day. Whoa. Okay, that's a massive number, and it immediately tells us one thing. Our system has to be incredibly good at writing new data, and fast.
Now, if we do the math on that, 100 million a day breaks down to about 1,160 writes every single second. But here's the thing, links are read way more often than they're created, right? Let's assume a pretty standard 10-to-1 read-to-write ratio. That means we're looking at over 11,000 reads per second. And that right there is a huge clue for our design. This system needs to be read-optimized, heavily.
And what about storage? Where are we going to put all this data? Well, if we're doing 100 million URLs a day for 10 years, and let's say each one is about 100 bytes, we're going to need around 365 terabytes of storage. So the main takeaway here is a simple in-memory solution is just, it's not going to work. No way. We need a real, durable, and scalable database. All right, we've sized up the problem. We know the scale of our reads, our writes, our storage. Now, finally, we can start sketching out the high-level architecture, the blueprint for our service.
We'll start at the front door, the API. Let's keep this really simple and clean. We basically need two endpoints. The first is a POST request to create a new short link. You just send the long URL in the body. The second is a GET request to handle the redirect, where the short URL code is right there in the path. Nice and simple. Now we get to a really key architectural decision. When a user hits that GET endpoint with a short URL, our server needs to tell their browser where to go next. But how? Should we use a 301 permanent redirect or a 302 temporary redirect? And believe it or not, this choice matters a lot.
So here's the trade-off. A 301 redirect is super efficient. The browser caches it, and next time it just goes straight to the long URL without even talking to our servers. That's great for reducing load, but the downside is we can't track those clicks anymore. A 302, on the other hand, forces the browser to check in with our service every single time. This is fantastic for collecting analytics, but it means a much higher server load. Since tracking clicks is usually how these services provide value, the 302 is almost always the right call here.
Okay, we've got our blueprint. Now let's get to the real heart of the matter, the core logic. How do we actually create a unique short URL? This has to be lightning fast and work at a crazy scale. First off, how long does this short URL even need to be? Well, let's use numbers, lowercase letters, and uppercase letters. That gives us 62 possible characters. We calculated that we need to support 365 billion URLs over 10 years. So a quick bit of math shows that a length of 7 characters, that's 62 to the power of 7, gives us about 3.5 trillion possible combinations. Yeah, that's more than enough room to grow.
So how do we actually generate that 7-character string? Well, there are basically two main schools of thought here, and this is a fantastic point to bring up and discuss with your interviewer. Let's look at both of them. Approach 1 is pretty straightforward. You just take the long URL, run it through a standard hashing function like MD5, and chop off the first 7 characters. It's simple, but it has a big problem: collisions. What happens if 2 different long URLs just happen to produce the same 7-character hash? You have to do extra work to fix that. But approach 2, base 62 conversion, is much more elegant. Here, we generate a totally unique number for every single URL, and then we just convert that number into a base 62 string. And the best part, it guarantees no collisions. I mean, that is a massive win.
Okay, so base 62 conversion might sound a little intimidating, but I promise you, it's not. It's just like the math you learned in grade school for converting numbers between bases. You just take your unique ID, say 1157, and you keep dividing it by 62. The remainders from each division correspond to a character in our set. So the number 1157 becomes a sequence of remainders that maps to the string 2tx. It's simple, it's elegant, and it is completely collision-free.
Decision made. We're going with base 62. It's the superior approach. So now, let's connect all the pieces and trace the full journey of a request through our system from start to finish. First, let's look at the shortening flow. So you, the client, send us a long URL. The first thing we do is check our database. Have we seen this URL before? If we have, we just return the existing short URL. If it's brand new, we generate a fresh, unique ID. Then we use our base 62 magic to convert that ID into a short URL. We save the whole package to our database, and finally, we send that new short URL back to you. Done.
Now for the redirect flow, which is our super important read-heavy path. A user clicks a link. The request comes in. The very first place we look is not the database. Nope. We hit a super fast in-memory cache, something like Redis. Remember those 11,000 reads per second? The cache is how we survive that. If it's a cache miss, then we go to the database, get the long URL, but, and this is key, we store it in the cache for next time, and then we send that 302 redirect back to the user.
So at this point, you've designed a really solid, functional system. This is a great answer. But if you want to go from a good answer to a great one, you need to go beyond the basics. Let's talk about the senior-level topics that really show you know your stuff.
This is where you really think about the real world. For instance, what's to stop a malicious user from spamming your service? You need a rate limiter. How are you actually going to store 365 terabytes of data? Well, you'll need to shard your database, split the data across many machines. How do you handle thousands of requests? You make your web server stateless so you can add or remove them easily. Thinking about these things, analytics, reliability, this is what separates a good design from a truly great one.
And that's the core design. Seriously, take a second. We went from a blank whiteboard and a simple question all the way to a fully mapped out, scalable system that can handle massive traffic. That is no small feat, so really, give yourself a pat on the back. Good job.
But I want to leave you with one final question, the kind of thing an interviewer might ask to see how you think about the business side of things. Now that this system is designed and it works, what is the single most important metric you would use to define its success? Is it uptime? Is it speed? The number of links created? Or is it something else entirely? Something to think about. Thanks so much for tuning in.